Take a moment to read the question. So f is a real valued function whose definition is given to us. A and b are real numbers and a lies in the open interval 0, 2. Also b is not equal to 0. We have to find out which among the given options is true about this function. So the first option says that there is exactly one value of a which makes f continuous. The second option says that the continuity of f depends on both a and b. The third option says that f is continuous if and only if a plus b is equal to 1. The fourth option says that f is not differentiable at exactly one point in its domain. How do we do this question? Well, the first step would be to write down the given function. So this is the function given to us. Now it is very clear that f is continuous in the interval 0, 2 as shown over here. It is also continuous in the interval from 2 to infinity. Now let us say that x is a number which lies between a and 2. Now therefore the function can be written down as mod of x minus a minus 1. Now since x is greater than a, we can write it as x minus a minus 1. Now to find out the left hand limit as x approaches 2 minus of this function, we can just take the limit of x minus a minus 1, and that limit would be equal to 2 minus a minus 1, which can be written as 1 minus a. Let us now find out the value of the function at x equals 2. So we get this, which is equal to 0. We now find out the right hand limit at x equals 2. So we get this expression, and that's just equal to 0. So for continuity at this point, we must have left hand limit equal to the right hand limit equal to f of 2, and therefore 1 minus a is equal to 0, or a is equal to 1. Now we can see that this depends only on the value of a. It does not depend on the value of b. Now we have the condition that a plus b is equal to 1 for continuity. Now a is already equal to 1, so that would mean b is equal to 0, which is not allowed. So this option is ruled out. Let us now consider differentiability. So the function to the left of 2 can be written down like this. Now this is not differentiable at the point x equals a. At x equals 2, when we consider x to be slightly less than 2, the function can be written down as x minus a minus 1, and therefore the derivative to the left of 2 would simply be equal to 1. When x is more than 2, the function can be written down as b times x minus 2 whole squared. So the derivative would be given by this expression, and therefore the right hand derivative is equal to 0. Now 1 is not equal to 0, which means the left hand derivative and the right hand derivative, they are not equal at the point 2. So this is another point where the function is not differentiable. Now considering all this, the correct answer is option A.